All right, up to this point, uh, there's certain sets of rules that we want you to follow for naming these compounds. And moving on to alkenes, we've briefly touched upon that. How would an alkene be different than that of an alkane? Yeah, it's got a double bond. So when you are naming that, you have to illustrate where that, or not illustrate, you would have to name where that double bond then is located. So one of the aspects we want you to do is look at page 725. So on page 725, it talks about alkene nomenclature. Okay, so I think it's worth reading that first. And I think someone in here had asked the question. It was over here. It was one of you two, I believe. That how would you state if it had two double bonds in the compound? That's not so much. It is possible, but we don't discuss that at this level. Again, I think you would agree with the way the author's presenting this material. Uh, One of the first couple pages was referencing isomers already, and I don't think that's something you really want to jump into until you really know what the alkanes are. So on page 725, it's not that we're jumping around. We want to take this into a nice logical order. So when any questions may arise, we can be on the same page. Okay, 725, alkene nomenclature. Use rules for alkane nomenclature on page 721 with the following exceptions. Okay, with number 1, it still says the same thing. Name the parent hydrocarbon. It should say parent chain, but locate the longest continuous chain that contains the double bond or bonds. If there's only one double bond, add the suffix ene, so you know it's an alkene then rather than an alkane. Okay. To the prefix corresponding to the number of carbon atoms in this chain. If there is more than one double bond, modify the suffix to that, so you would have, for instance, diene. That's more so of an application for organic and biochem for next year, should anyone decide that they want to take that class. And as it stands right now, there's just limited interest, which is still fine. Okay. Then add the names of any alkyl groups. So what would be an example of an alkyl group that we've talked about up to this point? Okay, a methyl group, propyl, ethyl, and isopropyl. Okay, so where are you getting those names from? No. Okay, so how do you get methyl from methane? That's right. What example did we give in class? It's derived from that. Remember, we wrote down Latin names of elements, so the English name that's given is derived from the Latin term. Okay? So as we continue, okay, longest continuous chain. Do that first. List any alkyl groups, okay? Then number 3, number of carbon atoms in the parent hydrocarbon. Number the carbon atoms in the chain so that the first carbon atom in the double bond nearest the end of the chain has the lowest number. And that's why we always state, think this sport. Golf, because you want to get the lowest score. And that's the same with naming and numbering these. You want the lowest possible combination, okay? So if numbering from both ends gives equivalent positions for two double bonds, then the number from the end nearest the first alkyl group. Okay, so it's hard to visualize an example like that. We will discuss that here in just a couple moments. Okay, number 4, insert position numbers. Place the double bond position numbers immediately before the name of the parent hydrocarbon alkene. Place alkyl group position numbers immediately before the name of the corresponding alkyl group. You've been doing that, you just never really illustrated that, put it into context like this. And then punctuate the name. So, If you were to look at the top of page 725, okay, I don't, I can see why it's incorrect. I don't know if it describes why that is, but when you look at this compound, okay, and I don't think it does explain it. Okay, so we have all of these on here, and then this branches up to something like that, correct? Okay, so first of all, what do you think? What's the longest continuous chain with this? Okay, when you just did that, and that's a classic trap to fall into. Look at right next to there on page 725. Why is there a big X through all of that? So that would be incorrect. You're finding the longest continuous chain, which is correct, but it has to go through the double bond. When you do that, okay, when you say that, if you went 1, 2, 3, 4, 5, 6, yes, that's the longest continuous chain, but what are you skipping over? The double bond. So you don't want to do that, okay? That has to be part of the parent chain. So that's how naming and numbering some of these alkyl groups and alkenes gets to be somewhat confusing, maybe. When you did this in physical science, we probably never did, I shouldn't say probably, I know we never did anything this complex. Yes, we perhaps did something with double bonds, something like this, and I think we even did this yesterday, if I'm not mistaken. So in this instance, what's the longest continuous chain here? It is 4, okay? So why is it you wouldn't be able to go 1, 2, 3, 4? You're skipping over that double bond again. You don't want to do that. So upon this case, we're going from left to right. So what's this called then? What's the parent chain? Okay, so butene. Did I hear butane? Oh, okay, I just want to make sure I'm not hearing things. I'm not. Are you sure? Oh, okay. All right. I mean, that's fine. We're going to make mistakes. So one of the things you people, please realize that when you do go off to college, you know, mistakes are going to happen. You're going to get sick. You're going to get run down. That's a fact of being in college. Okay? And the two things we always talk about mistakes. What are they? Say that again. Learn from the mistake and try not to repeat them. Okay, so we've named our parent chain. All right. What else do we got? 2 more things to name in that. We've got an alkyl group, which is a methyl derivative on which carbon? It's on the second carbon. So we want to do 2 dash, it's a little too high. 2 dash methyl, okay, and then dash. Do we need to write anything after that too? No, because that is only telling you where what is located. And this will come naturally with more practice. Again, we can go backwards. Again, in the box, what is this? The organic family. Okay? What is this? That's the parent chain. Okay? So then this is telling you something specific. There's nothing written after it. So it must be modifying what in the compound then? Where the double bond is. It's saying that we've got an alkene and that double bond is after the second one. This says we got CH3 or a methyl group and it's located on which carbon? Second one. There it is. Right there. I didn't write this correct, did I? You could. I think since there's a derivative on there. thought about that when I looked up. 1-butene. When there's a derivative on there, you do. Yes. I mean, at this level, we would not count that incorrect, but really that number should be on there because there's more than one. So if we had this, then you don't need that number on there. Then you just say butene. Okay, so taking this example and going back to this, just for that same reason, we're not going up and to the right, so we're not going to go to the left down and then to the right. So this has to be part of the parent chain. So that's where it gets to be just a little bit confusing if you're not careful. And this is why. Okay? This is something that we didn't point out to you when you were a freshman because we only want to pour so much information into your minds. Okay? So in other words, if we got a gallon's worth of information and you've got 2 liters up here, eventually what's going to happen when you start dumping that gallon into the 2 liters? It's going to overflow. It's good information, but that's correct. And so this is why we got to be careful. When we're talking about alkanes, if we wanted to put an ethyl group on here, that has to go on which one? Has to go on the third one. Okay? So we can put an ethyl group on the second one because there's a double bond there. That's what the difference is. Because if you say, well, if we can put an ethyl group on the second carbon here, well, let's put one on the second carbon on there. What is your parent chain as it stands right now? Hexane. But if we do this, pick him up and move him over, now we've got heptane. That's why it's a little different. You got to be a little more careful when you're dealing with double bonds as opposed to single bonds. Okay. Clear? Clear as mud? Close. Not pentane. And maybe you said pentene, but I thought I heard pentane. Yes. And trust me, this is recording. We could go back to the videotape. Nah, I thought I heard ane. Okay. So again, that's why you got to be a little careful when you're dealing with alkenes as opposed to alkanes. Otherwise, when you look at the example on page 725, maybe it does say that. Okay. Systemic names of alkenes. The rules for naming a simple alkene are similar to those for naming an alkane. The parent hydrocarbon is the longest continuous chain of carbon atoms that contains a double bond. We've illustrated that up here. Okay. The carbon atoms in the chain are numbered so that the first carbon atom in the double bond has the lowest possible number. Okay? So that's why you can't do this. And you really wouldn't know what to call this because you're going in the opposite direction. Okay? That's why you can't have this as hexene, because then even if you did, it would be what number? Even if you did go this way, it would be on what number? 3 after the third one. That's why going in this direction makes the most sense, because it's a lower combination. That's why we say think golf. Okay? So the position number, the name of the alkyl group placed in front of the double bond position number. The alkyl group has 2 carbon atoms. An ethyl group is on the second carbon atom of the parent hydrocarbon. So 2 ethyl, 1 pentene, and that's what you had said just a couple moments ago. All right. So we will not be concerned with two double bonds at this time. What it's saying is you just call it diene, but for right now, we're not too concerned about multiple double bonds. Okay, can we erase this? So now we get to expand a little further, and I told your classmate, go straight down the middle, right? Go straight down the middle. Not here, on the course. Yeah, why would you go straight down the middle? True. It's a lot easier to find your golf ball if you hit it straight where it's supposed to go rather than going left or right. Yeah. So if you see it going straight, then you can just walk right up to it. It doesn't always happen that way. Okay. So there's some more examples of those alkenes and alkynes, but we also will start talking about aromatic hydrocarbons. We'll reserve that a little more for next week. But page 730, functional groups, okay, other types of organic families. And as I told the freshmen, I'll tell yourselves, and even for those who take the full organic class next year, I just always have dealt with 3 carbon compounds. I really don't know why. Probably because that's the simplest way to go about it. So if we were to start from the simplest 3 carbon compound and keep moving forward, we would start with what? Okay, so we've got propane. Okay, and if we go to the next carbon compound, or next family, now we've got what? Gesundheit. Okay, then the next one, okay, now this is where mistakes can very easily be made. Okay, we're going to bond these 2 carbons, okay, but it's in a specific manner. Can this carbon have any more bonds on it? No, it cannot, because it has 4 now because of that triple bond. But how many more does this one need? Okay, so this compound is called what? Okay, so notice, like we've done in every instance up to this point, if you put a box around each suffix, that's telling you what? The organic what? The organic family or group. Okay, so alkane, alkene, and alkyne. Now some separate functional groups that you see on page 730. They use a 4 carbon compound. I have just always used that of 3 carbon compounds. Now I would not suggest looking over on that classification of functional groups on page 731. I mean, yeah, that's nice, but if you start looking at the general formula, it's just going to confuse you, okay? Because until you get a better in-depth understanding of that, it's not going to make any sense. So what we mean by that is, I think I got a picture of this. Trying to find this was a hard copy of what we've used in the past. Okay. Now you don't need to. That's what I'm saying. You'll just confuse yourself. We use flowcharts to try to help you out in to try to understand these. It just has a whole bunch of variables like the letter R. R is just saying any hydrocarbon and the rest of the formula. So don't get hung up on looking at that table if you choose to do so. It's just going to confuse you. That's more so of an application for next year if you choose to take that. Okay? So, with that, on page 730 then, stay away from 731. On 730, what are some other functional groups? We just stay on the top three. We've done propane already, where they use butane. So if we were to do the next two, but only 3 carbons in length, what would they be called based on this information on 730? Propanol, propanoic acid, right? Okay, what we had said is if we kept going down that table, I said we've done propane, the alkane. They use butane, we use propane. If you go to the next two, propanol, we said just keep it at 3 carbons, not 4. Okay? So what denotes an alcohol? An OH, a hydroxy group. So that's why we know that this is propanol, because it has that OH on there. Okay? And it can. This is what I'm trying to anticipate what it is you're asking, and what I'm perceiving is depends where it's at. That's why, does it change anything? Well, yes, it does. Okay? Yes, those are both alcohols, but they're 2 totally different compounds. Not always. If there's an OH on there, it just means it's an alcohol. That's all we know at this time. Okay? So, for instance, just look at this. Propene. It's just understood by saying propene that double bond is where? After the first one. But if we do this, we put another carbon on there. Now you have 2 propene. Does everyone? Yes. Oh, okay. I was afraid we were laughing and you were saying, this is too hard, we can't get. Okay. That's what happens when you jump to conclusions. I need my exercise. I think the second time I've heard that, right? Because you said 2-butene too, correct? Oh, did you say 2-propene? Okay. No, this is not 2-propene, it's 2-butene because you got 4 carbons. Okay? So what that means is it's just understood if there's nothing written here, it's after the first carbon. So it's just understood if this is on the first carbon, we would call that what? What's the suffix for an alcohol? Okay? So this would be called propanol. Okay? And this is why. Here's your organic family, OL. That means there's an alcohol. Okay? And this tells you how many carbons are in that alcohol chain. 3. Yes, there is. Yes, there could be. Correct. To methyl butane, not 2-methyl propane. Okay. So now, okay, naming this organic family, it's the same process. You always have to find the longest continuous chain. And it's still 3, so the prefix is what? Propan. Yeah, I know what you meant. Okay, just like this. That's propan. Okay, P-R-O-P-A-N. But we've got this branching off, so we know that this is a what? Alcohol. What's the suffix for an alcohol? Okay. And then the next thing we need to do is that hydroxy group or alcohol family on the first carbon? No, it's on the second one. So we need to say where it's at. Otherwise, if you just keep writing propanol, what you're saying is that OH group is on the first carbon. Okay? And this, it's kind of hard to establish so much with the alkanes, with alkenes and alkynes, but when you get to these functional groups, when these undergo the reactions, the pathways that these travel are way different just because of the way they're bonded. Okay? Mm-hmm. Okay? Are you sure you want to know the answer? It's more so for next year. Yeah. No. Okay. Okay, so your okay. Because if you start throwing these numbers in here and you start putting them before the prefix, how do you know which one's the double bond, which one's the hydroxy group? You don't. That's why you got to put the number back there. But that's a senior level application, not at this level.
So every time we're dealing with alcohol, there's gonna be just
Well, based off of this, yes. All right. Okay, left outside. How are we doing so far? Right outside.
Yeah.
Right middle. Left outside. Or left middle, I mean. Okay? So, it's no surprise that our next compound then is still going to be 3 carbons in length. Okay? But according to what you see on page 730, how do we denote an acid? It does. So, left or right? Okay? Because you can also go to the right side as well. But you said left. Yes. Okay? Alright. So, now, your longest continuous chain is still propan, but the suffix then, what do you notice on page 730 when they talk about the 4 carbon acid? What's the suffix? Yeah, OIC, okay? Propanoic acid. Okay? So when we reverse engineer this, or go backwards, yes? Well, okay? All right. So one of 2 ways. Notice we always talk about the organic family. Well, this does the same thing. You can just say with your acid or your OIC, that means acid. And then this is telling you what? Number of carbons. That's all that's telling you. Okay? So keep in mind that every time we do these, we say, here is your organic family. Okay? alkane and alkene and alkyne, all right? And then the prefix is telling you how many carbons there are, and then if there's something branching off of that carbon, like in this case there is. No, these have to be on the same carbon. Yes.
Oh, so the OH is the same carbon.
Yes. Yep. Okay. And even in this case, if this can have two numbers in two separate spots, just like that last example, okay? Because when you start doing that, you got to name where your OH is along with your derivatives.
Like, is that showing that there's a alcohol?
That. Hmm.
Wait, but can it be on like the second carbon? Or
No, you can't because it's got too many bonds.
got it.
Yep. Okay. Now, one of the things you might be thinking is, gosh, we're going over quite a bit. Yet, yes, we are. And you could say, well, if I wanted to know this, I would take this as a senior with the organic chemistry class. Yeah, I would agree too. But for the senior level class, you have to know all the reactions that go with it as well. This level, you don't. Okay? And one of the things that you will learn, especially when it comes to these reactions, again, just because of where these are placed, this will react totally differently than what this is. And they're produced in different manners as well. Just because, again, of that hydrogen bonding. That's such a big chemical, I suppose you could say chemical property that hydrogen has. It's hydrogen bonding that has that effect, because the reason we know that, water doesn't like to play by the rules because of the hydrogen bonding when it freezes. Why is that? Because it will expand when it freezes. The hydrogen bonding starts to press itself further and further away from the oxygen. And when it does that, that's why make sure you have antifreeze in your radiator in the fall. Because if you don't, that's a spendy deal to get a different radiator put in there. Same thing for those of you who perhaps have campers, or what else could there possibly be? Hot tubs, jacuzzis, or whatever. You need to, if you decide to winterize them, you need to flush that out, and then you need to put, can you just put any old antifreeze in there? You're shaking your head no, and that's correct. What do you need to put in there, do you know? I don't know, it's this pink stuff. Not chlorine, no. To winterize it. No, not chlorine. Close. RV antifreeze. That you can flush. That you can have be dumped on your grass. You can go down the sewer. You can do any of those. Regular antifreeze, no, it's not meant for that. Okay. Have we had enough? Not that we need more, but it looks like we've got something to hand out to you. Okay? So, I handed that out to your classmate. I said we hadn't talked about alcohols and esters yet. Or, oh, we should do esters as well. And ethers. You don't like that either?
Ether.
Okay, so that's fine. But this paper does have acids and alcohols on there. So, again, the rest of the time will be yours. And as we can see, this is due on the 7th, which is next Tuesday. You have in-class time. I will not be here. I'll be up on a field trip up to Brookings. So, we'll catch up to you next time.